Yeah, I think we're recording now. Good morning again, everybody. So, as I was saying backstage, things to look forward to in the last 2 weeks of classes. We'll have you still owe me problem set number problem set. Sorry, not problem set. Second part of the pre-final exam that will be due. Kailan nga sinabi kong deadline? Meron na ba akong sinabing deadline? Or wala pa? Or kinalimutan nyo na dahil na-trauma kayo dun sa exam nung Monday. So if I haven't set a deadline yet, I am thinking to officially make the deadline December 21. That would be set on Canvas. Ano? Ay, sayang, naka-record pala ako. But anyway, sige na, bubuko ko na. Huwag nyo lang akong kakasuhan. Ano? But I'll give you a 1 week buffer to submit it. That means the official deadline is December 21, 11:59 p.m. That's the last day of classes, actually the last minute of classes. Ano? So you can submit in Canvas. But I'll keep the submission bin open until December 28th, right before midnight as well. So 11:59 p.m. December 28th, pwede pa kayo magpasa. No deductions will be given for submissions made until the 28th. So kaya siguraduhin nyo yung mga sagot nyo. If you're sure about your answers, then submit it as soon as you can para masimulan ko rin siyang mag-grade kasi tambak na yung mga chechekan ko kasi medyo marami-rami na sila. And then the final project will be due January 11. I hope to release the questions on Thursday, on over the weekend. So by Monday 8 a.m. dapat pwede nyo nang i-download yung problem na assigned sa inyo for the final project. The groupings, we'll talk about it on Friday, along with some other mechanics for the second part of the pre-final exam. Now, question, can you guys see my screen or blanco rin siya?
Wala pa po, sir.
All right, let me try it again. Okay, I hope it's better now. Medyo Adobe yung gagamitin ko ngayon. Ayaw mag-load ng Notability ko. But this is the last part of the course or the redesigned course outline for Math 151. I figured it is due to the pandemic because when I was browsing it, medyo marami pang coverage yung 151 that I took in the olden days. Hindi naman olden days, pero nung undergrad ako, medyo mas marami pa kaming na-discuss sa 151, which includes, say, the solutions to systems of ordinary differential equations. Pero siguro it was necessary to redesign the course para mag-fit in siya in the online setup. That's why this is the last section for the course, which is basically Laplace transforms and initial value problems. But I think I gave you a sneak peek about it last time when we were talking about inverse Laplace transforms kasi kompleto na yung ingredients. Ngayon, pagsasama-samahin na lamang natin sila. And when I was looking at the examples today and trying to solve them, na-realize ko na yung example, yung sneak peek na example na binigay ko sa inyo last time, solvable pala siya, hindi nga lang gamit yung hindi lang gamit yung basic Laplace transform table or cheat sheet na binigay ko. Gagamitin niyo yung isang theorem na or isang illustration mula dun sa isang section, dun sa section before inverse Laplace transforms. I think it's still the Laplace transform of derivatives or the derivatives of Laplace transform para ma-solve yung inversion problem nung dun sa sneak peeking ng example ko last time. But essentially, what we try to do now is this. So we start with, I forgot how to do this here. Okay. So we start with an ODE. Oops. How do I write here? So we start with an ODE in the variable, say t, right? And then we want to avoid dealing with derivatives. That's why we transform the ODE problem in the variable t to an algebraic equation in the variable s, right? And this is done via the Laplace transform. And the idea is we solve the algebraic equation. So you solve the algebraic equation using usual techniques for solving equations. You'll get a function f of s or x tilde of s or whatever you call the Laplace transform of the dependent variable in the time domain. So makakuha ka ng f of s, your solution function, but in the frequency domain or in the s domain or in the Laplace domain. So what we want to do now is to bridge the gap between the solution that we got and what the solution to the original problem is. And that is done by doing or by using the inverse Laplace transform. So basically what we want to do, oops, what's happening? Ano nangyayari? If I press that, I should be able to write. Pero ayaw niya mag-write. Okay, yung pala yung dapat kiniklik ko. All right, so we do the inversion using the inverse Laplace transform. And to do this, we have seen last time that usually, aside from the Laplace transform cheat sheet that you should memorize, and some of the theorems dealing with derivatives of Laplace transforms and Laplace transforms of derivatives, and some of the results that we have seen in the illustrations, kailangan nyo ring tandaan paano nagpa-partial fraction decomposition. Ano? Kasi usually yun yung nangyayari. Kasi mga rational functions usually yung nakikita natin in the Laplace domain. And the goal there is to reconstruct the function x of the variable t as our solution to the ODE. Now, it's a long and winding road, so to speak, to get the solution x from an ODE. Pero usually, this sacrifice, dadaan ka sa Laplace transformation, mag-solve ka ng algebraic equation, tapos yung solution ng algebraic equation mo ngayon, i-convert mo pabalik dun sa time domain, that sacrifice is usually much easier than dealing the problem head-on of solving the ODE using the different techniques that we were using. And this is particularly evident kapag pinag-aralan nyo kung paano mag-solve ng system of ordinary differential equations. Okay, but let's illustrate this entire process so that you can decide for yourself, is it easier to do variation of parameters rather than solving it in the Laplace domain? Is it easier to use undetermined coefficients or reduction of order para ma-solve ko yung isang initial value problem? But ang pinakamahirap kasi dito sa sa solution via the Laplace transform ay yung pagkuha ng inverse Laplace transform. All right. So, but if you're adept enough to find inverse Laplace transforms, then this is the ideal method for you. Okay. Now, the only limitation of the Laplace transform or the solution by Laplace transforms is that it will only work for initial value problems because we will be using the Laplace transformation of the derivative. Note that here, laging may involved na derivative dun sa ating equation. So, and remember, kapag ka meron tayong Laplace transform ng isang derivative, right? So, kukunin mo yung Laplace transform ng nth derivative ni capital F. Ito ay equals sa yung derivative ay napapalitan. So, nth order derivative mapapalitan ng s to the power n times the Laplace transform of capital F minus, ito na yung magma-minus ka ng mga decreasing power ni s times increasing order ng derivative ni f pero evaluated at the number 0. You do this from k equals 0 until 1, right? Sorry, not until 1, until n minus 1, right? And this is what I wanted you to do in problem 5A nung pre-final exam, mag-convert ng isang ODE into the Laplace domain by taking the Laplace transform of both sides. And hopefully you remember this formula para doon sa task na yon, right? But let's see how this is done. All right, so our first illustration ay itong IVP na to, initial value problem, that we have y double prime of t plus y of t equals 0, and the initial conditions are that y equals 0, y at 0 is equal to 0, and y prime at 0 is equal to 1. And you see here, kailangan talaga initial value yung conditions na or initial values yung given conditions. Dapat yung value at t equals 0 because I need them para dun sa conversion ng derivatives into the Laplace domain, right? Always, the first step in the solution is to take the Laplace transform of both sides. Now, this guy will just be a Laplace transform ng y double prime of t plus y of t equals the Laplace transform ng 0, okay? And then this would be, I'll use the linearity property of the Laplace transform. So it's going to be the Laplace transform of y double prime of t plus Laplace transform ng y of t equals Laplace transform ng 0 is still 0. And then we'll take the Laplace transform of those in the left-hand side one by one, right? Laplace transform ng y double prime, it's just s squared. Since sinasabi ko kanina, conversion ng derivative in the Laplace domain. Second order derivative is transformed to a multiplication by a degree 2 power of s, so s squared, times the Laplace transform of y. Tawagin nating little f yung Laplace transform ni function y. So I'll have s squared times f of s plus Laplace transform ni minus minus, this would be s kasi decreasing power dapat si s. Nag-start na ako sa s squared. So susunod na sa kanya ay si s times increasing power naman yung derivative. So we start with y at 0 minus 1 times y prime at 0. So this guy is the conversion of, ito yung hirap ko rito, sorry. hindi ako, wala yung mga usual tools na ginagamit ko, ano? Pero itong tatlong terms na to, ito yung Laplace transform ng y double prime of t. Okay? And then plus the Laplace transform of y of t, that is simply f of s equal kay 0. Okay? All good so far? So, parang ganito, yung gusto kong gawin nyo kahapon, dun sa number 5A. Iko-convert nyo lang yung given differential equation into an algebraic equation in the Laplace domain, all right? Now, let's just remember what the initial conditions are. Initial condition, y of 0 is 0. I'll plug that into here. So that means y of 0 will be 0. So the middle term or the second term in the left-hand side will vanish. And then y prime at 0 is given in our problem. That's equal to 1. So we'll have, I'll go to the next slide, s squared. And then second term vanishes, minus 1 plus f of s equal kay 0. Double check ko lang. S squared f of s minus 0 minus 1 plus f of s equals 0. All right? And then the goal here is to solve for little f. Isolate little f to one side. So we can do so by first transposing the negative 1 to the right side. So we'll have s squared f of s plus f of s equals 1. And then I can divide both sides, or I can factor the left-hand side by taking out the common monomial factor f of s. So we'll have f of s, f of s times s squared plus 1 equals 1. Then we divide both sides by s squared plus 1 to get our expression for f of s. And then this is the solution in the Laplace domain. All we need to do is to get the inverse Laplace transform of both sides to recover the solution y to our ODE. So that means here, the next step is to take the inverse Laplace transform of f of s, and then inverse Laplace transform of 1 over s squared plus 1. And then the left-hand side will just be the solution y of t that we're looking for equals inverse Laplace transform ng 1 over s squared plus 1. That is just sine t. Right? Sine of 1t. And that's it. That's our solution. And you see here, I didn't use any derivative-related step other than taking the Laplace transform. Pero yung Laplace transform, it's almost mechanical to us kasi hindi naman tayo dumaan sa definition ng inverse Laplace transform. Right? And there we go. That's the solution to our initial value problem. Sir, bakit hindi pwedeng ganyan lamang yung mga nasa exam, ano? Bakit kailangan may mga tangent x at may mga x e to the x? Ganun talaga. Kapag ako yung magsasolve, dapat madali lang. Lalo na kung live ko siya gagawin, ano? Tapos, kaya nyo na yan. Kaya nyo nang gawin yung mga solutions para sa mga mas komplikadong problems. Okay? So, any questions with this one? I hope this is pretty straightforward just to get our engines running. Ano? Let's say one more complicated example. Y double prime, actually, simple pa rin to kasi two terms lang yung nasa left-hand side. So we have y double prime plus yy plus equals 4 sine 3t. But we have nice initial conditions, y of 0, hindi pala nice, akala ko parehas 0, pero y of 0 is equal to 1 and y prime of 0 is equal to 0. Again, the first step is to take the Laplace transform of both sides of the equation. You can start your solution by writing L of this guy plus this guy equals L of this, or you can go right away and do the Laplace transformation. So bahala na kayo kung saan nyo sisimulan. But I really love starting with the basics. So I'll take the Laplace transform of y double prime of t plus 9yt equals the Laplace transform ng 4 sine 3t. Ganito yung tekniko ng undergrad ako para alam ng teacher ko na alam ko yung first step. Kahit magkamali ako ng pagla-Laplace transform, alam niya na alam ko yung gagawin. Kukunin yung Laplace transform ng both sides, so I should get partial credits for that kahit mali-mali yung pagkuha ko ng Laplace transform. So basically, it's a trick to get more partial credits. Ano? So kasi iba yung alam nyo in theory, pero yung implementation, that's another question. But you should get credit for knowing what to do in the first place. Kaya gusto ko halos step by step lagi sana yung solution. All right? And then I will apply the linearity. Papakita ko, oh sir, alam kong linear yung Laplace transform. So pwede ko siyang isulat ng ganyan. But again, if you're confident, you can skip some of these steps. Kaya lang, minsan, I have some experience this semester that students made careless mistakes at the beginning of their work, but I cannot give them partial credits because I didn't see kung ano yung ginawa nila. So I cannot trace what happened, and I don't know what's going on in their heads when they did the solution o ano yung misconception na nakita nila. So that prevented me from giving them partial credits. Ano? So pero kung ganito kaklaro or ka-step by step yung solution mo, mas madaling mabigyan ng partial credits. Ano? Sino ka ba teacher ko sa 151? Isip ko kung si Sir Lawas yung teacher ko ng 151. Ay, hindi, si Ma'am Loyola pala ang teacher ko ng 151. But anyway, kasi ganun din siya mag-solve. Ano? Super detalyado rin si Ma'am Loyola mag-solve. But anyway, so yeah, let's take the Laplace transform of all of these terms. We have y double prime again. So it's s squared Laplace transform of y. Let's just call it little f, right? Minus s times y of 0 minus 1 times y prime at 0. And then plus 9yt, I'm going to use linearity of the Laplace transform for the second term, wherein the scalar 9 can come out. And then it gets multiplied by the Laplace transform of y, that's f of s. And then Laplace transform ng 4 sine t, 4 sine 3t. is 4 times 1 over s squared plus 9, right? So you can write a condition if you want. The condition here is s greater than 0, but I won't penalize you if you don't write it because theoretically we're always looking at the long-term behavior of s. So we are always assuming the Laplace transform is defined, and that's easy to assume because you'll just tell your reader that, oh, s was chosen sufficiently large enough so that everything exists, right? And then now it's a substitution. I'll have s squared f of s. Y of 0 is 1 here. You see the initial condition there. So I'll have minus s here times 1. And then y prime of 0 luckily is 0, so the third term vanishes. So we'll be left with plus 9 f of s equals 4 over s squared plus 9. And then I don't know if I can copy paste anything from here. Mahina pa naman yung memory ko, no? But the next thing is I will add s to both sides, and then it will become s squared f of s. Sorry, kailangan kong bumalik. Limot ko na yung kagad. Plus 9fs equals 4 over sine squared plus 9. Plus s. Lahat ng walang f of s ay nilipat ko sa kanan, alright? Para makompute ko si f of s by factoring f of s out of all the remaining terms on the left-hand side and dividing both sides by whatever that factor is, right? So I'll have f of s times s squared plus 9 equals 4 over s squared plus 9 plus s. And then therefore, f of s is equal to 4 over s squared plus 9 quantity squared plus s over s squared plus 9. So we'll need to take the inverse Laplace of both sides. So if I take the inverse Laplace of both sides, we'll get x of t back. And this is equal to the inverse Laplace transform of 4 over s squared plus 9 quantity squared plus 4 over s squared plus 9, right? Right. And then now, I don't think I'll have any troubles with the inverse Laplace transform of the second term that we have on the right. 4 over s squared plus 9, ang inverse Laplace niya lang ay 4 sine 3t. Ano yung sabi ni Crisel? S po sir yung isang 4. Aling isang 4, Crisel? Yeah, sorry, thank you. This is S. Right. So yung nasa second term yung S, thank you. So ang inverse Laplace transform niya ay cosine, ano? Kasi S pala siya, hindi siya 4. So madali siya, medyo mahirap lamang yung first term, 4 over S squared plus 9 quantity squared. And I guess this is where I got stuck also last time, ano? Nung inisip natin yung inverse Laplace transform dun sa example kong binigay. Pero meron akong kodigo rito na maliit. Hindi ko to naalala last time because this is one of the illustrations in I think section 4.5 if I'm not mistaken, right? Isa to sa mga pinrove natin na statements ng inverse Laplace transform ng 1 over s squared plus k squared quantity squared ay equal sa 1 over 2k cubed sine kt minus kt cosine kt. So I'm going to use that information or that fact that we already proven before to get the inverse Laplace transform of the first term, right? Because here I can factor out the 4, right? Lalabas ko na tong 4. Matitira na lang ay 1 over s squared plus 9 squared. So kung i-apply ko tong theorem na to, that means k is equal to 3, right? So that means I'll have 1. It would be composed of 2 terms. So I'll have 1 over 2 times ang k ay 3. So we'll have 3 cubed. Tama ba? 1 over s squared plus k. Tama. K is equal to 3. So that means I'll have 1 over 2 times 3 cubed times sine of 3t minus 3t cosine of 3t. Okay. So yan yung inverse Laplace transform ng first term plus inverse Laplace transform ng second term, s over s squared plus 9, that's just cosine ng 3t. Essentially, this is 4 magiging 2 over 27. Tama ba? 3 cubed is 27. Sine 3t minus 12t cosine 3t plus cosine 3t. And that's our solution. Okay? Does that make sense? Are my computations correct? Yun pala. So, siguro naman ngayon kilala nyo na ako na wag yung paniwalaan yung mga yung mga computations ko kaagad. Parang kahapon may nagsabi na parang mali yung hint ko sa 5B at saka sa number 4. Sorry naman kung mali, pero yun dapat yung design eh. So baka may algebra ako na commit na mistake. But did anybody match their answer to number 4 and number 5B? Or may magkaibang constant? Sabi ng mga nag-special exam, ano daw, hindi raw equal. Hindi ko pa siya na-double check. Pero tingnan ko. Sorry naman kung mali yung hint, ano? But hopefully hindi kayo nagpadala dun sa fake news, ano? Anyway, you have to show your solutions naman. So, makikita ko, ano? So, hindi pwedeng, sinabi ni sir, sagot, ito yung sagot. So, sulat nyo na lang. Babasahin ko naman yung solution nyo line by line, ano? Okay? Alright, and then I hope you realize here the complication. Ang mahirap lang talaga dito ay yung paghahanap ng inverse Laplace transform. Alright? Because the conversion, at least we're dealing with elementary functions, yung mga functions na alam na nating i-Laplace transform. So, ang dali. Nung conversion mula sa time domain papunta sa Laplace domain. And the solution of the equation in the Laplace domain is pretty straightforward. Maning-mani sa inyo yon, easy peasy. You can get f of s. The real challenge is to convert that little f of s into a function x of the independent variable t. Okay? So isa pang example. Right, so here we have, okay. Yes, Crisel, yung 1 over 2k cubed ay hindi nakadistribute dun sa kt cosine t. Right. So yung 1 over 2k cube, sorry, hindi. Dapat pala siya ay naka-distribute. Thank you, Crisel. KT. Yeah, dapat naka-distribute siya. Sorry about that. So at least natuto na si Crisel na wag akong paniwalaan kagad. So dapat naka-distribute siya dyan. So this guy should have what? This guy should have 2 times 3 cubed sa denominator. And then pwede mong cancelin alin. Meron ako ditong 2, so ito ay magiging 6. Tapos meron pa ako ditong 3. So ito ay magiging 2 na lang. So magiging 2 over 9 na lang yung second term. Right? So minus 2/9 of cosine 3t. 2/9 t cosine 3t. Yeah, thank you, Crystal, for that. So dapat naka-distribute siya doon sa buong term. Yeah. Yes, naka-distribute siya dapat doon sa entire sum. Bakit hindi na lang nilabas yung 1 over 2k cube all the way out of the Laplace transform? But anyway, probably that's how the slides wanted to present it. So yeah. Okay, so let's take a look at the last example. Y double prime of t minus 4y prime t plus 4yt equals 4 cosine of 2t. The initial conditions are y of 0 equals 2 and y prime of 0 is equal to 5. Okay, again, first step, take the Laplace transform of both sides. So I'm going to do it medyo ididiretso ko na siya. But again, I prefer that you write all the steps of the solution, even the trivial ones, so that I'll know what happened kung doon kayo magkamali? Ano? Laplace transform ng y double prime is s squared f of s minus s f of minus s y of 0 minus 1 times y prime of 0, okay, minus 4 times Laplace transform ng y prime. So that's s f of s minus 1 times y of 0, right? Kasi decreasing dapat yung power ni s. So meron na akong, nag-start na ako sa s to the 1. So yung susunod, yung subtrahend, yung unang subtrahend ay s to the 0. And then ang ka-combo niya, increasing derivative. So magsisimula ako sa 0th derivative ni y. So y of 0 muna. And then hindi ko magagamit si y prime kasi nasa first derivative pa lang naman ako. Kasi first derivative lang yung ni Laplace transform ko. Right? And then plus 4 f of s equals Laplace transform ng 4 cosine 2t. So it's going to be 4s over s squared plus 4. All right? So ito yung equation natin in the Laplace domain. Then let's try to simplify first. So I'll still have s squared f of s. Then y of 0 is 2. So I'll have minus 2s. Okay, kasi ang y of 0 ay 2. And then minus y prime of 0 is equal to 5. So may minus 5 dyan. Tapos minus 4s f of s plus 5 times y of 0. So magkakaroon dito ng plus 10. Tama ba? Kasi magiging plus 4 times y of 0. Bakit 10? So ito ay 4 times y0. Ang y0 ay 2. So 8 lang siya dapat. Tama, no? 8 lang. Minus 4s f of s plus 4 times 2. So 8 plus 4 f of s ay equal kay 4s over s squared plus 4. Right? And then we can, we know that we will retain all those with f of s's in the left-hand side. So we'll have s squared f of s minus 4s f of s plus 4 f of s equal to dun sa lahat ng walang f of s. Okay. And then I'll have, so this guy will transfer. So magkakaroon tayo ng negative 2s. Meron pa bang may s? Wala na, no? So I'll have a plus 2s here. And then minus 5 plus 8. So that's gonna be plus 3. Pero paglipat sa kabila, minus 3 na siya. Okay? Tama pa ba siya so far? Alright. Tapos ngayon ay if-factor ko si f of s mula dun sa left-hand side. So I'll have s squared minus 4s s squared minus 4s plus 4 times f of s equals 4s over s squared plus 4 plus 2s minus 3 plus 2s minus 3. Okay. And then we get f of s by dividing both sides by s squared minus 4s plus 4. This is 4s, and then this is s squared plus 4 times, actually I can factor this, right? So pwede ko na siyang isulat na s minus 2 quantity squared kagad. S squared minus 4s, yeah, plus 2s over s squared. Sorry, s minus 2 quantity squared minus 3 over s minus 2 quantity squared. Tapos kukunin ko na ngayon yung inverse Laplace transform ng both sides. All right. Now, I will cheat a little bit here by asking you to do the algebra. to verify the algebra for me. So sabi dun sa slides, I hope it is correct. So I can double check it. Ano? So this is equal to 2s cubed minus 3s squared plus 12s minus 12 over s squared plus 4 times s minus 2 squared. Okay. OA yung fraction bar ko. So, iksiyan ko siya ng konti. Okay. So, that's when you combine or when you expand the left-hand side, the right-hand side. Okay? Tapos ngayon, ito si f of s, kailangan kong kunin yung inverse Laplace transform of this huge fraction over here. So, ngayon ko kakailanganin yung partial fraction decomposition. Although, yeah, kasi at least one of this, ito, wala tayong formula para sa 3 over s minus 2 quantity squared. Hindi, meron pala. Kaya ko itong pwede ako mag-exponential shift muna dito, right? Mag-multiply ako ng e to the 2t dun sa inverse Laplace transform para maging 3 over s squared na lang yung i-invert Laplace transform ko. So that should be fine. Same thing here. Magkakaroon ako ng sine and cosine, so that's also fine. Exponential shift dito by multiplying by e to the 2t, all right? So ang ilalaplace transform ko na lang dun sa second term ay 2 times s plus 2 all over s squared. That should be easy. Pero may problema pa rin ako rito. Kailangan ko mag-partial fraction decomposition dun sa first term, all right? Pero ang sabi ng slides ay ito daw yan. Sabi ng slides, hopefully tama yung slides, ano? So, ang sabi niya ay, that means, magpa-partial fraction decomposition ka, so that means f of s is equal to 2 over s minus 2 plus 2 over s minus 2 squared minus 1 over s squared plus 4. Okay, so please verify that these are indeed this is indeed the partial fraction decomposition of this function here. Okay, purely algebra lang naman yung kailangan nyo dyan. If you forgot partial fraction decomposition, then you can go back and review it and try it in this example, right? But after the partial fraction decomposition, I think we're ready to take the Laplace transform, right? So inverse Laplace transform, term by term, right? So we'll have x of t equals 2 over s minus 2. So it's going to be e to the 2e to the 2t, right? So tama ba? 1 over s minus k, k is equal to 2, lalabas yung 2. Okay, that's fine. Plus, here I will do exponential shift. So I'll have e to the 2t times the inverse Laplace transform ng 2 over s squared minus, madali lang yung Laplace transform ng third, ng inverse Laplace transform ng third. So that is just sine 2t. And then now we'll have 2e to the 2t plus 2e to the 2t inverse Laplace transform ng 1 over s squared. Ang inverse Laplace transform niya ay n equals 2. So, n equals 1 factorial. So I'll have t squared here. Tama ba? Ang Laplace transform kasi ng t squared ay 2 factorial of, that is t lang to. Kasi ang Laplace transform ng t to the 1 ay 1 factorial over s squared, which we have minus sine 2t. And that's our solution. All right? Ang kagandahan din dito ay hindi na tayo dumaan dun sa solution ng homogeneous equation, solution ng non-homogeneous equation, tas magsosolve ka pa ng linear equation para mahanap yung values nung parameters, nung generic constant C1, C2, and so on. So paglabas mo sa Laplace domain, makukuha mo na kagad yung solution dun sa initial value problem. But again, the challenge was to do the partial fraction decomposition of our resulting right-hand side or our resulting expression for f para mas madali siyang makunan ng inverse Laplace transform. Okay? And I guess that's it. You have several exercises here to choose from. Ang dami pala, no? Sabi ko pa naman dito ako pipili ng ilalagay dun sa second part ng exam. Pero, sige, pwede ko nang burahin to. Teka, magbabawas ako okay. At ang saya niya na the end, 3 exclamation point talaga yung nilagay niya. Pero sige, yun na lang. Para dun sa part 2, number 1, sa pre-final exam, you can choose 1 out of the 8 remaining. So pwede kayong pumili ng isa dun sa 8 natitira sa exercise 4.7, except, hindi, yeah, dun sa 8. Okay na, pili kayo ng isa dun sa 8, yan yung pre-final exam part 2 number 1. So gagawa ko ng submission bin kay Canvas na PE 2.1. Alright? Pili lang kayo ng isa sa 8 na yan, tapos yun yung ipapasa nyo. Traditional submission lang, PDF ng solution nyo. Alright? So, single PDF file consisting of your detailed solution to one of the problems here in exercise 4.7, and you'll get 10 points para sa pre-final exam. And then I'll think about the remaining 10 points na ibibigay ko sa inyo sa Friday. Right? Para masimulan nyo na rin gawin yung part 2 ng pre-final exam. Right? So meron pang PE 2.2. Antayin nyo yon by Friday. Kasi ibabrowse ko ngayon, ibabrowse ko bukas yung mga pinasa nyo sa akin nung Monday. Alright? Okay, and I think that's it. Do you guys have any questions about the topic today? May sinabi pala si Rensis. May 1/2 pa po ata dapat sa tapat ng sine 2t. Sine 2t. Do you mean Rensis dito? Saan magagaling yung 1/2? Sa partial fraction decomposition ba? Or maybe I copied the partial fraction decomposition wrong. Let me just double check the slides. Thank you for calling my attention there. Let's see. Yeah, may 1/2 nga siya. Pero saan nanggaling yung 1/2? Yeah. Thank you. Kasi nga pala yung formula natin ay dapat ang Laplace transform ni t. Yeah. I forgot about the constant requirement. Kasi may k nga sa numerator yung Laplace transform. So dapat ko itong isulat na 1/2 times 2. Kasi yung Laplace transform ng sine kt siya ay equal sa k over sine ng so s squared plus k squared. Siguro ito yung mali ko dun sa nung ginawa ko yung 5b. Mukhang may nakalimutan akong constant dun sa numerator. So yeah. I missed that. Nakalimutan ko sa formula, may k pala yun sa numerator. Hindi lang basta 1. Thank you, Rances, for that one. Yeah. Doon siguro nanggaling yung mali ko dun sa question 5b. Okay. Other questions? Yes, Mark. Itong problems, yung part 2 ng pre-final exam, alright? Part 2 ng pre-final exam, so that would be PE 2.1 and PE 2.2. Ang ilalagay ko kay Canvas na deadline niya ay December 21, pero open yung submission bin hanggang December 28. at walang deduction kung lampas na ng December 21 kayo magsasubmit. Right? So pag pasa nyo pa rin siya kay Canvas hanggang December 28 para doon ko siya checkan. Mas mabilis kasi mag-check kay Canvas kaysa via email. Ano? So, yeah. Okay, para lang hindi ako mademanda na meron pa akong pa-deadline after December 21, ano, which is technically the last day of classes. Pero naka-record tayo yan. Pinapahamak nyo ako, guys. Joke lang. So, any other questions? So if none, so that's the end of the technical content of the course, but we'll still meet on Friday to talk about the final project. Yung mechanics lang naman. Siguro mabilis lang, mga 30 minutes lang yung meeting natin. And then hopefully I can also give you the second question in the second part of the problem set. So you can start doing it para medyo masigurado nyo na makakabawi talaga from the first part of the pre-final exam. All right? So thank you guys. Enjoy the rest of the day, and let's see each other again on Friday.